All right, my ABI students, welcome back from break and the current pandemic crisis. Hopefully everybody's staying safe. And this video is going to take off from where we left off. And if you guys remember, we left off where we were on lecture 3, looking at doing exploratory data analysis, and we started talking about taking summary of the data, and we started talking about using ggplot. I introduced you guys to ggplot about doing some sort of visual analytics. And a great way to show the power of visual analytics is using the Titanic data set. All right, if you guys go to Blackboard right here, you'll see the Titanic.csv. Go ahead and download that, right, and place it in your class folder. Now, I'm recording this video because ideally these YouTube videos now are going to be used as our classes, and our normal class time, I think it was 2 o'clock on Sundays, I will log on WebEx and treat that as more of the Q&A / office hours for the session. So the idea is you guys, before class, before that time, you guys go through the YouTube video, right? And then we can talk about it for anybody that needs to talk about the code or the material, any general questions during class. And the reason I'm doing this is because a lot of people are on their bandwidth, and they might have a problem connecting at that time, or their internet might be spotty at that time. So if I pre-record these lectures, that way you guys can download the video. Some people download the YouTube video, or you can watch the YouTube video when you guys have time and your internet is consistent. Also, you can speed it up, slow it down. It's totally up to you, right? Depending on your expertise. So I feel this gives a little more flexibility, but at the same time, the only downside is if you have an error or you have any questions, this is not really we're not really talking two ways here. So that's why I like to still have the class time via WebEx to discuss any problems, any questions, to fix any possible code. And I think this flexibility is the most optimal way to try to recreate the classroom setting and the rhythm that we develop. So hopefully we'll get into rhythm soon about this. I'm going to try to get these lectures loaded up as soon as possible, so you guys do have that time before your class to review the material in a comfortable pace, Now, like I said before, if we download that Titanic data, I'm going to go. Let's load it up. Hopefully you guys remember how to do this. Import data set. All right, my Titanic data set, I believe, is, am I an ABI? I'm not even an ABI. Oh, perfect, right there. Right, again, Titanic, this is going to be the name of the table. There, yes, is a heading. There's a heading column. Strings are the factors. Absolutely not. Right, you guys know factors now. You guys can do this yourself. Import it. Boom, done. Notice the table pops up. All right, excellent. We have the Titanic data. Now, like I said before, the Titanic data is a very famous data set. Everybody, every university, when they're doing any kind of visual analytics or they're just doing any kind of machine learning problems or along those lines, it's a very famous data set to use. This data set, let's look over here in the top right window. It has 887 rows and 8 columns. This is real. This is the real Titanic data set, which is wild. Okay, it's there. It's all there. All right, except for Leonardo DiCaprio. That was just a movie, and there's plenty of room. Like we said before, there's plenty of room for both of them. Stupid movie. Anyway, all right, so we want to use the Titanic data to do a visual analytics example, all right, a practical example, right? And the practical example we want to do is we want to go ahead and try to answer the question, was it indeed women and children first, right? You guys know the saying, anytime there's a fire or any kind of catastrophe, people are always saying women and children first, right? This was back in the days. Now we're all equal. I'll be shoving everybody to the side to save myself, all right? Thank God for that. Now, let's start by checking out the data, right? Let's start by checking out the data. First thing we do, let me open up a script file. All right, let me save the script file as Spring 2020. I will save it as, I do already have a lab 3, but I'll save this as a Titanic one. We already had lab 3.1, so but I'll make this a separate one. I'll make this lab 3T for Titanic. All right, there we go. All right, now, first things first, library, data.table. Let's go ahead and convert this, guys. The name of the data is Titanic. Sure. Now it's a data.table. What else we want to grab? We're doing visual analytics. Grab ggplot. Oops, sorry. Library ggplot 2. All right, and we imported it. Excellent. All right. From here, let's do our thing and view the table. First things first, Titanic. Excellent. You can see it's a data table right here. Data frame. We have a survive class, passenger class, a name class. Okay, so we have the names. All right, excellent. We have the names. Sounds good. So this is a name. This is more descriptions. This is not really going to be categorical data for us because we can't take the names and whittle them down to, like, remember the rule, Miller's rule of 7, right? We can't whittle it down to 5 or 9 categories. This is just some sort of descriptive column that we have to either get rid of or not work with. Now, here, survived. Okay, so here we go. Survived. It's an integer. All right, it's an integer. 0 and 1. 0 and 1. Perfect. Survived column is basically telling us what? It's telling us who survived, if they survived, yes or no, right? Let's survive, yes or no. Survived is a categorical column. These zeros and ones represent whether the person survived or they didn't survive, okay? This one, passenger class, it's also an integer. 3132. Okay. This is, again, these 3132s, what are they? First off, let's confirm using the unique command function that our survived only has 2 data sets. Sorry, if I do it like that, I got to give the name. Dollar. Excellent, it's just 0 and 1. All right, fantastic. So let's do it for passenger class as well. Let me type it up here because it gives me a nice drop down when I do it up here. Titanic, dollar, passenger class. Yes, 312. We know what that means. 1 is for first class, 2 is for medium class, 3 is for, I guess, economy, if you want to think about that. Name, we already talked about. There's nothing we could do with name. It's not really categorical column or numerical column. It's something we shouldn't really have. It's something we're not going to deal with in our analysis, right? Either we could take a subset of this data or we can just leave it there, but this is something that later on we might deal with, but not right now. Sex, aha, okay, good. This is a character. It looks like it's only 2 fields. This is going to be easy. This is as well categorical data. Age is a number. Excellent. Sibling, spouses, integers. All right. So this is another categorical data, but we'll leave it alone because I don't think we're going to even look at this. We don't need to know about the spouses. We don't need to know about the parents, children aboard. And they have a fair number. That's pretty cool too. But we don't need to look at that. We could have looked at that as well. I mean, we might look at that, but I mean, it's not necessary. All right. So here, there's definitely three columns that need to be converted into categorical columns, right? They're right there. Please excuse the syntax here. Don't use as.factor. Don't use as.factor, right? As.factor doesn't give you the same flexibility as the factor function. Use the factor function. Use the factor function. And I'll do it right now in front of you guys. All right, so here, let's do it. Do it like the code. I should probably update my slides over here. Yeah, just don't do this. All right, so let's go ahead and convert it into categorical data, guys. All right. If you guys remember all the rows, I want to do which one first? Let's do survive first. It's there. colon equal. Now, what is survived? Let me ask you this. Survived. This is categorical column. Is it a nominal or ordinal? The answer is it's nominal. It's not ordinal. Some of you guys might be like, no. So life has a greater magnitude than death. No, it doesn't work that way. It doesn't work that way, all right? They're two complete things. Life and death are people that survived or didn't survive. It's a binary variable, right? So this is a nominal, not a cardinal data set. And we could just say survived because it's not ordinal. I don't have to put ordered equals true. And because it's an integer, I don't even really have to worry about labels. If I don't really have to worry about labels, but if you want to, that's fine. But here I'm not even sure about who survived and who didn't survive. Usually the way they do this is 0 means didn't survive, 1 means survived, right? But we'll confirm this. Boom. All right, so that's categorical data. Now let me do it for the next one, which is passenger class. Now passenger class, all right, this is a different beast. Passenger class, is this ordinal or nominal? Ladies and gentlemen, this is ordinal, all right? And because of the fact that these are numbers, I don't have to explicitly say, because these are numbers and the order is first, second, third, right? I don't have to explicitly state the levels because it'll just fall into its numeric order. All right, passenger class. Ordinal equals 2. Sorry about the noise, guys. All right, sorry. This is ordered, not ordinal. Apologize for that. Boom. All right, so we're done with that one. And now right there, the sex, right? Male and female. Is this ordinal? Some of you chauvinists might be like, yes. My chauvinists, my feminists might be like, yes. No, this is nominal. All right? Sex, and we're done. All right, let's go ahead and run this again. And now, looky, we have a factor here. We have an ordinal factor here. That we have to leave for now. We have a factor here with 2 levels. Fantastic. All right, fantastic. All right, good. So we got that out of the way. All right, we're ready to party now. First things first. Let's look at who survived and who didn't survive. And here it's saying to you people right here, we see it clearly, right? When we run we graph just to survived. Remember, survived, these are all categorical columns. Survived is a categorical column. Remember, this has been 2 weeks. Actually, for you guys, I think it's been like 3 weeks. Okay? No, it's been, I think, 2 weeks, 2 classes. Yeah, you guys missed 2 classes over here. Survived, right, is now a categorical column. How do you visually view a categorical column? Huh? Bar chart. Okay, how do you view a numerical data? Histogram or box plot? All right, how do you view, how do you compare a categorical to categorical column? A bar chart with split colors of the bars. How do you compare categorical to numerical? Box plot, where the x-axis is your categorical data and your y-axis is your numeric data. And what about numeric to numeric? Scatter plot. The scatter plot should be seared in your guys' minds because you guys have done linear regression over and over again, which is the next chapter, by the way. All right, so let's go ahead and do this. Let's go and graph the survived ones. Remember how ggplot works? Your first function, ggplot function, is to put in your data set. That's your first parameter. And then this part you could do either in this function or the next function, but I like doing it all in the ggplot function. Again, you get your own style. We call the aesthetics function, which pretty much says basically, okay, which columns am I calling from Titanic and which axis am I putting them on? How do I plan to use these columns? So because I'm doing a bar chart, I just simply want to have on the x-axis survived. All right. Now, that set up the basic graph. Now, how are we going to view that graph? That's the plus. The plus is always layering commands on top of your initial command. So this here sets up our, if you remember, our data, the table we're using, and the columns we're invoking, and where we are invoking those columns. This stands for aesthetics, but you could think of it as like axes. Where are you putting it? We're invoking the Titanic data. We're using the survive column. We want to put it on the x-axis. Fabulous. Now, how do you want to view it? That plus, another layer. Now we're talking about aesthetics. I want to view it as a bar graph. Boom. Just like before. I don't know if it's big enough for you to see, but you guys should be able to see this. Now, we talked about this before. I'm not sure what 0 and 1 means. Usually 0 means didn't survive and 1 means survived. What does this mean? More people died than survived. More people died than survived. That's what this means, right? By the way, do you want to know what there's a few tragedies to the Titanic. There's two main tragedies to the Titanic. One tragedy was that they didn't have enough lifeboats because they wanted to clear off the lifeboats on the deck so that the first class passengers had more space on the decks. That's one of the tragedies. The second tragedy is that when the Titanic initially hit the glacier, it wasn't a big deal. Yes, it hit it. There was a leak. It was a small leak. It wasn't a big deal. The leak was so small that they had enough time to radio in the most recent port, right? And have a boat send out a ship, take half the passengers, sail them back to that port, then come back out from that port, pick up the rest of the passengers, and then sail back to the port. And I think they still had some more spare time. The problem is that after they hit that Titanic, the crew panicked, and they're like, what do we do? This is embarrassing, et cetera, whatever. They're like, oh, or partially they're arrogant. Like, oh, let's just do full steam ahead and just ram right through the bad boy. When they did that, that's when they tear this massive gash and basically doomed a lot of people. So in the sense, the engineering held up. It was the human error, as always, that caused the big problems, right? We can probably add an analogy to the pandemic going on right now, the way we're handling it. All right, so boom. Right off the bat, visually, I don't have to look at any numbers. You don't have to look at any of the rows. I don't care if it's 887 rows or 887 million rows. Right off the bat, we just answered a question here using visual analytics. More people died than survived on the Titanic. All right, more people died than survived on the Titanic. 0 means died, 1 means they survived. Okay, again, the question is survived. 1 usually means true, 0 means false. So if it's false, they survived, they died. So bam, we just answered a question here. And again, did not look at one row of data. All right, that's the whole point of visual analytics. All right, nice. Next, let's take the same graph. Let's add some more aesthetics to it. The first one we're going to add is, let me copy and paste this. First of all, look how cool this is that I can just copy and paste and make additions to the graph. This blows away your precious, Tableau, where it's clicks, clicks, clicks. This is the power of using R and Python, because you can just do copy and paste and make small changes really fast and make graphics and doing analysis much faster than you can do in your precious Tableau. You still have to learn Tableau because it's just very marketable at this point. All right, so I have an error. Theme BW. Typo. All right, I think I need to put my grids in first. So first of all, let me put my labels in first. So theme W. Oh, there you go. I just mistyped something. So When I type in theme underscore BW, guys, look what happens. See how the graph changes? The black, the gray and the black from behind went away, and now you have these grids, and you have this nice white, and now you have this, it's slightly nicer, right? Why is this? What is this theme? What is all this theme nonsense? If you look at when I clicked on the theme part here again, let me close this and do this again. What's going on here? Right? All these different themes. Well, I mean, believe it or not, and this gets kind of annoying, in corporate America, when you're doing certain graphs, either you're printing graphs or you're visualizing certain graphs, there's certain colors you're supposed to use. And depending on the type of chart you're doing, you want to use certain groups of colors. Why do they have this? It has something to do with marketing. It has something to do with people easier to visualize certain colors contrasting with others. I was in a situation where I was working, and I was doing stuff for obviously I was doing quantitative reports on portfolios, and the marketing person is like, "Oh, you have to fix this." I'm like, "Fix what?" They're like, "The colors are wrong." I'm like, "What the hell do you mean the colors are wrong? The numbers are right, right? This is what you want. This is the right. These are the right numbers." Like, no, you have to change. You have to change this, that, all purely aesthetic stuff. I had no idea what the hell they're talking about. So this is where these themes come into play, and ggplot has a lot of these themes preloaded to make your life much easier. Like, you want to use theme black and white when you're printing something on a paper, on a presentation, because it's much clearer to see than if I did something like this, if I printed something like this, right? To some of you guys be like, I don't get it, I don't see the difference, but apparently in black and white, it's much different having that gray against that white. All right, now let's go ahead and add here it says labs. This is basically where you can change the title and the labels. That's what lab stands for, the labels. So here I'm going to make a different label for, if you notice we have survive down here, but it says count over here on the y-axis. That makes no sense. So here I'm going to change it to passenger count. All right, because that's basically what it is. How many passengers survived and died. Y for the y-axis. And by the way, what happens is we kind of start to run out of space. You can, after the plus, you can do an enter, and it'll give you, notice that tab is there. All right, the plus will be here, and that tab will be there because it's part of the original line. All right, and title, I believe it's title equals all right. Boom. And now, guys, nice little title, Y label. All right. Just aesthetically makes it slightly more pleasing. All right. Moving right along. All right, now, like I said before, that's great. We know that more people died than survived. But let's say now we want to say, okay, remember the first question, what are the questions we're answering, guys, here? Was it women and children first? By asking that question, we're testing, what are we asking? We're asking, hey, did more women survive than men survive? Did all the women and children survive? Right, that's basically what the question is trying to answer, all right? So, survival rate, we have the survival rate right here. Let's break it down by gender. Now here is where I'm going to show you a nifty little trick, okay? Oh, I don't have it here. Gym bar theme, okay, excellent. So we want to basically now, actually no, it's here. We basically want to, we did this before previously in lecture 3. The bars, this is how we compare, by the way, categorical data by categorical data. We want to change the fill, basically the colors within the bars, to be colored by another column. And that's why we go into our aesthetics part again, because remember, in aesthetics, we choose the column. So we already chose survival. We wanted, before over here, we said on our x-axis, we had whether you survived or you didn't survive, okay? But now we want to know the survival rate by gender, okay? So what we're saying here is, okay, put the sexes down first. Let's do that first. Let's do the sexes down first. That's what we actually should do first. Copy this and make the change that I want to make. That was sexes. That was, I'm sorry, survival, and this is by sexes. Now, this is purely, this graph is showing me what? This graph is showing me basically how many female passengers there were versus male passengers. And as we can clearly see visually, right, what can we see, guys? We can see, hey, you know what? There were almost about twice as many male passengers than female passengers. There are only twice as many male passengers than females. Excellent. Once again, simply by running the graph, I've answered a question about the data. There are twice as many males as females. Again, it does not matter if there's 887 rows or 887 million rows. I answered this question right off the bat. There's something more I know about the data now. This goes to the heart of exploratory data analysis. All right, now back to this question. Okay, great. Now, out of those males and females, how many of them survived? How many didn't survive? Now, this becomes a categorical by categorical analysis. Now, I'm going to go back to my AES function and say, you know what? Not only do I want to invoke the sex column, I want to invoke the survived column. And the survived column, I want it to color. I want to use that column to color the subparts of the graph. Just copy and paste this down here and do fill equals survived. Boom. All right. What do you guys see here, guys? On your machine or right here on the video? Well, okay. All right. There's almost twice as many men. There's almost twice as many men. And percentage-wise, I mean, we don't have percentages on our side. If we could change it to percentage on the y-axis, it's a little more advanced. But from just eyeballing this, percentage-wise, many more percentage of men perished versus women. Women did die. Yeah, so it looks like women did die. But their percentage-wise, they did a heck of a lot better than the men, right? It's not even about numbers at this point, right? It's not even the fact, oh, there were more men, that's why more men died. No, percentage-wise, I mean, multiples, we can see it here, people. Point blank, so many more percentage-wise men died than the female died, all right? So we can basically start even answering the first part of a question, be like, yeah, man, looks like at the very least, looks like women were first. Looks like women were first, right? Okay, now, let's switch gears up a little bit, and let's do by passenger class. Let's look at the breakdown by passenger class. All right, so let me go grab this one. Alrighty, here. Okay, passenger class. And again, notice how it puts in a nice proper order for me right here, 1, 2, and 3. If this wasn't categorical columns, then you would notice that this would not be in the proper order, 1, 2, and 3. It would be in whatever order it showed up in the data. All right, but because it is categorical column, boom. Now, we have this many first class passengers. All right, fantastic, great. We have this many second class passengers, which is interesting because it's actually less. We would expect it to be more, but it seems like but it's less. And then this actually makes sense. We have most of our passengers tend to be third class passengers. So this is kind of interesting. It seems like if second class is kind of weird in the sense that I guess if you could afford it, why not go away first class? So it's kind of a weird situation. But all right, fine. From here, let's see their survival rates by passenger class. And now again here, fill equals survive. Sorry, this capital. Boom. Look at that, guys. All right. Okay. First class. You know what? It's interesting. You would think that first class actually you have a much better survival rate with first class, but no, not really. I mean, obviously more first class people did survive, But I mean, it's not that. It looks like what is it? What 2/3 of maybe 1/3 of first class passengers did not survive, right? Which in my mind, that seems really high, right? It seems really high, especially if you're up there, right there. You have the boats. You know, what's the problem? We go to second class passengers. It's 50-50 at that point. Wow, it's a shocker, right? And you go to third class, and then you have something that it's more expected for us, right? That majority of the third class passengers did not survive. Now, can be attributed to, we can throw a lot of things out there. We can attribute to the fact that they were lower in the ship, right? We can also attribute to the fact that they didn't have the boats for them. We can also attribute by the fact that maybe there's class racism, if you want to say that, with the with these people. So it could be a bunch of things. It could be a bunch of things in play here. But I mean, this is something we tend to expect more of. All right. Okay. All right. So again, learning a lot from the data. Some things we expected, some things a little bit shocking. First class. Now, here's a little twist for you guys that you guys haven't seen before. And it really starts opening up the power of ggplot to you guys. All right. Show me the survival rate by gender and class. Here I introduce you to something in ggplot called Facet_wrap. Facet_wrap. What is this? This allows you to create multiple graphs side by side by different criteria. All right? So let's start off with creating the gender graph again. I have that. Where is it? Right here. There it is. Excellent. Let me copy this. And again, notice the ease at which I do it, unlike in Tableau. Yes, I will keep taking shots at Tableau. Now, what I want to do is I want to add the passenger class to this as well. I want to split this graph right here. This graph right here, which is survival rate by sex, I want to split it out by passenger class. How do I do this? I simply add, I mean, I can add it anywhere I want. Typically, I like adding it faster wrap a little before the theme, before any of the aesthetic stuff, so I'll add it right here. Tilde, and then I will add passenger class. And don't forget the plus to link it with the stuff from the bottom stuff. Close it up a little bit here so you can see it. All right. Now look at this. Forget Tableau. Imagine doing this in Excel all of a sudden. Look how easy we did that, people. Like I said before, ggplot is all about data exploration, visual analytics. Boom. We took that graph that was male and female's survival rate. That was fancy in itself. But now, using Facet Wrap, we put another dimension of analysis into this bad boy. We broke out the male-female survival rate, right? The male-female survival rates by passenger class. Let's look at first class now that we have this. Okay, all right. Now, this is what we're talking right here, if you follow my mouse. Almost, there's still some females that died that didn't make it, right? But most of them did very well. First class females, you're doing it right. You're doing it right, okay? Most of them survived. Now, look at the males. What is going on there? What the hell? This is very, very upsetting to somebody like me. More among the males, right? We talked about that. There was a nice big chunk of males, first class passengers that died. Yeah, it's the males. The females made out like bandits here. Almost perfect, almost, right? The males, even in first class, more men died than survived. More men died than survived, okay? Let's look at second class. Second class, okay, all right. More percentage of females died, but overall, they're still looking pretty good. Look at that graph. They still did pretty good even in second class. My God, but look at the men. They took even a bigger hit in second class. A bigger hit in second class. It's not until the third class that it looks like for the females, okay, it was 50-50 for the females at this point, right? the third class females definitely didn't have the same considerations as the first and second class female passengers did. And obviously, you know, this is England in the 1900s. Class division is a big thing. So it's 50-50. But look at the men. My God, look at the men. You're as good as dead. If you are a third class passenger male, you are as good as dead. Right? Look at that low percentage survival rate right there. So small, right? Pretty much same thing with second class, right? And even first class is shocking. So again, we can see this because of facet wrap. And look at the descriptions and what we see, what we can say clearly about the data. It is because we're using visual analytics. And again, difference between, it doesn't matter if it's 887 rows or 887 million rows, the graph doesn't care. The graph is still going to give you the graph. It's fantastic. Your y-axis numbers are just going to be much larger. That's it. That's going to be the only difference. All right. So at this point, I think it's safe to say for us that we can say, you know what, women first, or we can say high society women definitely first, right? High society women definitely first. Third class or the common female, it was a flip of a coin. Really was a flip of a coin at that point. It looks like they were all over the place, right? But definitely the consideration was given to women of the higher classes. All right. So now let's start. Now the next part of the question is, okay. The next part of the question is, okay. All right. Women, we answered the part about the women, but what about the children part? Children first, right? Was it children first? So for this, how do we isolate the children in our data set? Remember, we have the age column. So let's do a distribution of the age column. But the age column, if you remember, guys, if we remember STR, Titanic, right? Age, it's a number. How do we view numbers? Histogram and box plots. So let us do the histogram first. Right? Let me copy this. No, let me copy something simpler. I shall copy this right here. All right, I'm doing a histogram, so X is going to be age. All right, I'm going to change this to histogram. And if you remember, with histogram, we don't have to put a parameter in there, but the way histogram works is either we have to put how many bins we want or the width of the bin. So in our case, look, we're talking about children. Let's make it five. Let's do 5-year-old increments. All right, let's do 5-year-old increments. So let's do bin width equals 5. And later on, I'll show you guys how to make these graphs a little more clearer, the histogram graphs. All right, okay. So we have the 5-year-old graphs here. All right, it's not telling me much. All right. So let us do this. All right. Now what I want to do is it's kind of hazy, but I think, oh, do I show you? I don't even do it. But let's go ahead and do it. I don't do it in my slides, but let me show you here so it makes it make it look clear, a little clearer. First of all, let's add some colors to this, right? So the color, let's do fill here equals yellow. Okay, it's yellow, but it's still hard to see. So let's add the the outline around the boxes. Let's make it a different color. Let's make that color. The color controls the outline, the borders of the colors. So let me make it a little bit bigger. Color equals black. All right, zoom in. Yeah, much better, much better. All right, 0 to 5, 5 to 10, 10 to 15, 15 to 20. All right, it's 5. All right. So it looks, everything is kind of shifted, but That's basically where we're getting at. Okay, fine. So we have widths of 5. All right, fantastic. Now, from here. Oh, and by the way, you guys see a 20 over here? So I say this is a 0 to 5. Remember, the right side is inclusive, the left side isn't. So literally, the 20-year-olds would be in this bar graph because it would be 0 to 5, exclusive, 5 to 10, 10 is exclusive, 10 to 15, 15 is exclusive, 15 to 20, 20 is exclusive, 20 to 25. So any 20-year-olds would be in this graph. This is why this bar graph lines up above 20, right? And again, I'll show you a little bit later how to shift the histogram to make it much more intuitive, because even someone like me just confuses the heck out of me. But anyway, let's look at the age distribution, all right? Okay, all right. Got almost somewhat of a normal distribution going here. We do have kids, right? Not that many, but we do have kids. We have obviously many people from 20 to 40-year-olds right here. Our biggest size right here makes sense. Actually, massive amount of 20, 25, 30, massive 25 to like 35-year-olds, right? Which makes sense. A lot of young people, shockingly. That was probably more the poorer class, if you want to think about it, if you want to break it down by passenger class. That's probably, we would probably see a lot of this age group over there, right? And then we do have this huge skew over here. And look at that. Look at that, man. Got an 80-year-old up in there. 80-year-olds, 75-year-olds, 70-year-olds. Got some old people up in there. And my guess is they're probably wealthy people. I mean, they're obviously going to be wealthy people. If you're that old, my God, why are you going to a ship like that? Unless you're going to enjoy yourself. All right. So that is the histogram. We get a nice distribution of the age. Now, let's go ahead and break that up by survival. All right, let's see the age. Let's just jump right into it. Let's see the age group by survival. All right, and I'm going to add a few labels. I have passenger count here. I'm going to add the an x-axis for age equals 5. All right, for bin width. I mean, you don't have to if you don't want to. You could if you want to, but more importantly, let's add fill equals survive. So I will go ahead and delete the aesthetics from here, because now I want the column to dictate the color in the bar graph. Fill equals survive. So now we can see the survival by the age. But you know what? I will put the black outline. It just makes it a little more clear from aesthetics point of view. Oh yeah, that was ugly. And see, as you can see, that's so much more clearer when you have the black in there. All right, let's look at this. What are you guys seeing? What are you guys seeing? All right, all right, all right. We're seeing sadness over here, okay? 0 to 5, 5 to 10, 10 to 15. All right, right here. Little kids did not make it. This is sad. I apologize to some of you, but it's true. They didn't make it. 0 to 5, 5 to 10, 10 to 15-year-olds over here. Large amount of those kids didn't work. You know, it's possible the 10, 15-year-olds were actually, working also, believe it or not. No, I mean, these are all actually passengers. So, I mean, these are lower class. It could be very lower class. I mean, we could look at the passenger class, but large percentage of these guys didn't really make it either. Here is 50-50 as well. This is, I believe, 20 to 25. So this is 15 to 20. Look at that. Look at that. And over here, between 20 to 40 or 20 to 45, massive, large amount of these people didn't make it. All right, again, large percentages. The percentages seem pretty standard over here in terms of who didn't make it and who made it. Some of the old people obviously didn't make it, and then look over here, all the way to the right. 80-year-olds, all right? There's some 80-year-olds there. Now, they're probably rich, but they made it. These are straight up gangsters over here. At 80, they're traveling on the Titanic maiden voyage across the freaking Atlantic Ocean. They hit a freaking glacier. A lot of people die. They don't. All right? That's a straight up gangster over there, that 80-year-old. All right? So, we start to see that, look, some kids didn't make it. Let's do a little more analysis here. Here now, let's remember it's a numerical data, so let's look at let's look at the box plot, and let's see if we see a difference in the survival and non-survival, the distribution. Now what we're doing, guys, here we're doing a analysis of the people that survived versus their age. Okay, we want to see if we want to do a comparison now between the people that survived and their age. Survived is a categorical column, age is a numerical column. Boom. Categorical and numerical analysis. If we want to do a comparison between a categorical data, categorical column and a numerical column, box plot. All right, box plot. Right, and again, what are we looking for? We're looking to see between the people that survived and didn't survive if there was a difference in the distribution in the age. Okay, because remember, we're trying to see if as a child you had a better shot of surviving versus not a child, right? So here, survived age, I'll take this again. I have the age, but I'm going to switch it up a little bit. All right. So remember, I'm doing it between age and survived. So it's going to be X and Y. Which type of data, when we're doing a comparison between numerical and categorical, which one goes on the x-axis? Categorical. Which one goes on the y-axis? Your numerical. Change this to box plot. Don't need any of this. That easy. Run this and check it out. All right. Now, remember, survived. These are people that died. 0 died. 1 survived. Okay. Do we see a really big difference in the distribution of the ages? The ages are right. The ages. Oh, I should change this, by the way, so we don't get the y-axis. Actually, not passenger count. Now it's age. All right, let's do it again. Do we see a big difference between the people that survived and didn't survive in terms of between the people that survived or didn't survive in terms of the distribution of the age? Do we see a big difference? We don't. Those box plots look somewhat similar, right? I mean, I see that this is slightly, the people that died are slightly older than the ones that weren't over here, the main data here, but the distribution seems the same. We do have some outliers here of people that died. So a lot of the old people look like they died, right? So that we can say, except for this guy right here, this person. That goes back to that 80-year-old. And look, now because it's one dot, we know it was one person. This gangster of an 80-year-old. This is going to be from now on called the gangster 80-year-old, or the 80-year-old gangster right here. This person survived. All the other people didn't make it. Except for this person right here. All right. So here, this one's not looking. This one's not leaning much towards telling us that, you know what, it was children first. Sadly, right? Let's continue. Let's break it down a little bit more. All right. Now, oh, here I basically show you. I don't think this is going to be that good. This is going to tell us that much information also. But this is, I'm introducing you guys now to the density curve. So we haven't talked about density curves that much, but let's go ahead and do the density curve, right? Let's go ahead and look at the age, gender, and class. Now we're finally putting class into here, so we're going to bring the facet wrap. All right. So let's go ahead and do the facet wrap with passenger class. Here I'm actually doing by sex and passenger class, and we'll get to that in a second. Oh, am I missing? Oh, I missed my plus here, so I didn't have my theme. All right, excellent. All right. Okay, now that we broke it up by passenger class, notice 1, 2, 3. Oh, by the way, I didn't point this out before. See that tilde over there? After the tilde is how we separate it. It's basically saying to the right of the tilde is saying we're separating it by columns. To the left of the tilde means we're separating it by rows. You're going to see that in a second. You saw that in my slide. You're going to see that in a second. So here, okay, all right, all right, all right. And by the way, 80-year-old gangster, yep, first class, right? This guy was rich and living large. Look at and this is what I'm shocked about right here, guys. This is what I'm shocked about. All those other old people that didn't make it, okay, they were all third-class passengers. What were they thinking, man? Well, I guess no, it was supposed to be the ship that didn't sink. Okay, so I guess they were enjoying themselves. So a lot of these older passengers, they didn't make it. All right, they didn't make it. In terms of the how it's skewed, in the first class, the younger people are slightly skewed younger at this point. Second class, people survive skewed younger. Third class, skewed younger. So this looks like, here we can clearly see a much clearer picture that the people that survived were of a younger age, relatively, right? And that 80-year-old gangster is rich. All right, now over here, it's saying, okay, so let's take it one step further and add another dimension. Let's have not only our age and survived, right? And not only passenger class, but let's add gender as well. Gender as well. And again, the Facet wrap comes into play. Let me just copy and paste this so that you guys have. I will post this code so you guys have it. All right, and to the left here, I'm going to put sex. Bring that back. Look what happened here, guys. So because the sex was to the left of the tilde, that got separated out by rows. So that's why you have all the females on the top row, all the males in the second row. Because passenger class was to the right of the tilde, that dictates the columns that you want it broken up by the columns over here. So here we have the first class, second class, third class. All right, so what do we see here, guys, in terms of age? What do we see? What do we see? All right, we see down here are the males, up here are the females. All right, females wise. First of all, back to our 80-year-old gangster. He's a rich man. Done. And he survived. Done. What else do we see? Females. Ooh, look at this. Up in the females, for some reason, first class females, the people that died were actually a bit younger for the females. Look at that, a bit younger. A little bit strange there. Females, everything else over here, females, second class, younger is about the same here. For third class, about the same here, but okay, wow. These guys were all men, old men. One old woman, mostly old men didn't make it. All right, but look at how granularity now of us doing the analysis. All right, cool. Not cool, but you know. So now I'm going to introduce you guys to the density curve. All right, we can do that same graph, but now we can place a density curve over it. Now the density curve takes a alpha parameter, and the reason it takes the alpha parameter, you guys know what alpha is, that's transparency, because density curves actually are made from one behind the other, right? Get one behind the other. So I don't know how much we're going to get from this. I feel it's a little more confusing, but this is actually a great opportunity to show you guys the density curve. So, you know, I always like taking the opportunity to show you guys a little something extra. Ooh, object not found, that's right. That is because there is no y. So we will do back to fill. X is back to age, that's right, density curve. Our number goes in the x-axis. And now we're going to use fill again. Another error here, alpha. And now we are good. Look at those density curves. All right. So the idea here is basically with the density curve is maybe we can see a large amount of we can see the survival and the people that made it and didn't make it side by side or on top of one another, right? And we can get some things out of here. So first off, right here, first class female, age is, look at the age. The age now is on my x-axis, guys, right? So let's look at the first class female. First class female, this is something very disturbing. There is a female, it looks like a baby, right? Didn't make it. First class female baby. I don't know what happened there, right? Male boys, the male baby boys first class, they were good. Look at this. They were good up until here. They were good. So in terms of first class boy, male, children, indeed they were first. Something went horribly wrong over here. Here, females, okay, now for second class females, the little kids, again, x-axis, age axis here, they made good, and the boys, second class, they made good, all right? So outside of this outlier, first and second class, children indeed was first, all right? Now we come to the females here, and now you have the people that died behind it and the people that survived in front of it. Now you see that, okay, now you have, I mean, it looked like you had more of these children survived than died, but a lot of children, little children died. Female third class children died. Here again, you have, looks like you had more male kids in third class survive, but you did have some boys that did die, right? And we see this. We see this right here. So we can see that. Let's now take it another step further. And let's go back to our histogram. All right, let's go to our histogram and break it by the colors. And now I think the histogram will give us a better view of what happened. And remember, a histogram is basically, a density curve is basically a histogram where the histogram bin width is as small as possible. It's something like 0.001 width or something like that. That's why it's a smooth curve. But I think from here, we'll get more out of the histogram. Let me just go ahead and grab this. All right. Actually, instead of doing this, let me just type. Yeah, let me do this. It's two spaces, but now you can see everything more clear. All right now. Okay, now look. Okay, this is what we've been working up to basically. All right, look, guys. So it looks like here there was indeed a baby girl that for whatever reason she died in first class. I think it was just a mistake. For whatever reason she died. It's really sad, but that was the only casualty from the female point of view of children. I mean, there was no other. There wasn't. It looked like there wasn't any other baby girls there. That was the only baby girl for the first class females. It looks like the next age over was a 20-year-old. Or a 15 or 10 to, not 20-year-old, but a 15 to 19-year-old looks like. All right, 15 to 19-year-old. After that, there's some females. Other than that, there was a baby girl and she didn't make it. But first class baby boys, they all made it. Look at that. All the kids. So first class, so women, first class, second class, women, and children, for the most part, they were first. All right. Over here, 20-year-old first class passenger didn't make it. And here, as you can see the breakdown now. You can see the breakdown of the ages of the passengers, the male passengers, first class passengers that didn't make it. All right. Again, I'd like to put up our 80-year-old gangster grandpa over there. You damn sure believe that guy made it. Probably lived till 100 when he came to the States. All right, but over here we have a lot of blues, Females doing fantastic. All right. Second class, again, look at all these blues. Again, blues have survived, all right? We got some reds over here, but overall, females doing fantastic. The males, okay, the children, all right, they made it. The boys, they did good. They made it. After that, it's a disaster show for the guys, the second class guys. In this age bracket, they did not make it, including the older gentlemen. All right. Females in third class, this is where we get some mixed signals here. We had more of the kids that made it that didn't make it, but the kids, female girls in third class, there were a percentage-wise a number of losses. All of them at this age died. So it's pretty spread out, the deaths, in terms of ages. And after a certain age, all the third class women died. The older women didn't make it, which makes sense because they have, it was, you know, a lot of physicality was probably involved in trying to get to those lifeboats. And so, you know, you can only imagine what was going on. Males over here, again, so here, this is really sad. The baby boys of the third class passengers, more of them died than survived. Here was 50-50 between the 5 and 10-year-olds, even more between the 10 and 15, and the numbers just start spiking at this point for the third class. Though, I mean, if you were a third class male passenger, we talked about before, it was pretty much a disaster for you, right? Pretty much a disaster. And after a certain point, it was not going to happen. But I mean, so look, I mean, after looking at the data set, look, we didn't look at one number. And I think this is where my slides finish finally. So we didn't look at one number. And again, yes, it was about 800, 900 rows of data we looked at, but who cares? Who cares? Again, it could have been an unlimited amount of number. That's the point of visual analytics. Look how quick we did that analysis, right? Look how many questions we answered. And I mean, look how many statements we could have made about the data in the statements. And we could have, the understanding we now have over this data. For God's sake, people, we now want to know who this guy is. And now we can go back to the data and find out who that guy is, right? The hero of the story right here. We can also go back if you wanted to and find out who that little baby girl was, right? But the point is, we answered this question now. We started off with the question, and we can say, hey, you know what? First class and second class women and children first, hands down, hands down. Third class women, you had a fighting chance. Men, just call it a day. All right, at that point, you're Leonardo DiCaprio. Just call it a day. You're not going to make it. All right, but aside from the fact the sad factor of this data set, the coolness of this is the power of visual analytics. This is what ggplot does for you, right? You can quickly go in and do a basic summary of the data set, all right? A quick summary of the data set using visual analytics and get such a feel for the data set. And more importantly, this data set was nice and clean for us to answer and view things, but some of the data sets, they might not make sense when you're looking through them. Like for example, when we were looking through our earlier on in the chapter, we were looking at some of the Twitter, Facebook, and Google AdWords, and we're looking at how advertising is spent across these three marketing mediums versus small companies, large companies, and a lot of stuff didn't make sense. Same thing with the season stuff. So this drives a lot of great questions, and from those great questions and the answers that become apparent to you is where great analysis is born. That's where great analysis is born, when great questions start getting generated. There's a saying, I think I had it before in my slides, that a precise answer to the wrong question is worse than a guesstimate answer to the right question, right? You're not going anywhere. You're not going anywhere in terms of analysis if you don't ask the right question. And you can't ask the right question unless you get a feel for the data, right? No matter how large it is. And that's why visual analytics, data exploration, visual analytics is so important and so valuable and growing as a field. All right, so guys, this concludes our Titanic aspect of the data set. We are now going to, the next video will now be going over practice set 3. And after practice set 3, if there's time, I like to make my videos total around 2 hours and 40 minutes, just like the class. If there's time, we're going to get started with the lecture 4. I'll keep lecture 4 as a separate video, but we can start talking about lecture 4. And lecture 4 obviously is linear regression. All right, linear regression and multilinear regression. It's basically meant to serve as a refresher for everybody, because everybody has done linear regression multiple times in different classes in your undergrads and whatnot. If you've never seen it before somehow, then I mean we can talk about it. I mean, we can you can ask me questions and we can talk about it, linear regression, right? But there's no way that we can talk about analytics if we don't talk about linear regression. All right, and we'll talk about that a little bit later. All right, guys, thank you. And the next video will be on practice set 3.